July the 2nd, 2022. As you're looking at the update 45 minutes ago from the National Hurricane Center, now we have tropical storm warnings up. This is going to be Tropical Storm Colin. And the blue line indicates where those tropical storm warnings are. This thing came out of nowhere. We saw it yesterday, setting just off the coast, throwing some rain across the Carolinas and Georgia. But what's happened is that high-pressure system that we've been watching over the Atlantic, the one that has steered Tropical Storm Bonnie across the Mexican Peninsula, is keeping this thing pushed ashore. It looks like it's going to break free, probably go right through the Nags Head on the Outer Banks, that region. But again, wasn't a lot of time to prepare, and it's 4th of July weekend. So if you've got plans there, you've got friends that are going there, family, make sure that they are aware of the warnings. I'm sure they are if they're on the beach. You got flags. But the rip currents are very dangerous. Also, check your local tide tables and see, as we're going to look at some more information on the timing of this, but check that against your tide tables if you got small craft, things like that, or you're planning some kind of a beach excursion. Just be aware of what's going on. In the overall look, again, here's Colin setting again onshore, northeast South Carolina. It's going to hug that shore, come out, it looks like, through the Outer Banks. Bonnie now is almost into the Pacific Ocean, and this thing's traveling. It's still 40 miles an hour, 35 knots. Pressure's at 1,002 millibars. Its movement west at 12 knots, 14 miles per hour. This thing could become a Pacific hurricane. This was at 11:09 Eastern time, and there comes my huskies in here. What are y'all doing? Anyway, Bonnie's there. This thing we may have to watch also. It's just a 10% chance of development, 48 hours, but it has maintained the low pressure area through the Windward Islands and is now into the Caribbean. This tropical wave continues to produce a broad area of disorganized shower and thunderstorms over the Windward Islands and eastern Caribbean Sea. Upper-level winds are not conducive for significant development as the system moves west-northwest during the next few days across the Caribbean Sea. And this is the wide Atlantic satellite image. It gives you a great image of all three of the systems we're watching. Here is Tropical Storm Bonnie, again, about to enter into the Pacific Ocean. Here's Tropical Storm Colin, sitting there. And this system is unnamed yet, but if it maintains enough to break through the what they're calling the upper level wind shear, we'll just have to keep an eye on it. It's only a 10% chance of development in 48 hours, but it's there. You have to watch it. Now, also, you've got a system that's just came off of Africa. Don't know if that's going to hold together or not, and you can see some of that Saharan dust starting to form a new wave in the last few frames there coming off of the African coast on the right. Now, looking at a Tropical Storm Bonnie for all our friends down in Mexico and Central America, it is setting here on shore. It's about to be offshore by 2 p.m., 40 miles an hour, and then slowly speed up. Notice 65 miles an hour by 2 a.m. Monday. It's going to skirt the coast. That's going to throw waves towards you, maybe some good moisture. And then a Category 1 Tuesday at 2 a.m., 75 miles an hour, getting up to an 85 mile an hour Cat 1, and then maintaining that through Thursday at 2 a.m. We don't know if it will fizz out before it gets out and a threat to Hawaii or not. We'll keep an eye on that. Now, here's some of the spaghetti models going back to Colin. CMC has the most northern track here. After it comes offshore, they're pretty much agreeing where it's going to come out. Somewhere in North Carolina, it looks like. And then you've got the Navy model that's very close to the CME, slightly south of there, and the others very headed out into the Atlantic. The TABD model shows that this system is turned back. Now, it's by itself in that, but we've seen stranger things happen. You've got that big high pressure area setting in the Atlantic. Remember that. And here's the update and the timing on Colin. You've got the storm setting here. It's going to stay ashore as looks like a 40 mile per hour storm. That's sustained winds near the center. And then by Sunday at 2 p.m., 40-mile-an-hour storm south of Norfolk and coming back offshore. Still maintaining that tropical storm strength that entire time. It's moving at 8 miles an hour northeast, central pressure 1012. They're saying the tropical disturbance off the coast of South Carolina that I was talking about earlier has developed into Tropical Storm Colin Saturday morning, according to the National Hurricane Center. They're saying that the storm became better organized overnight with winds reaching tropical storm strength. Colin is being steered by an area of high pressure over the western Atlantic and moving northeastward, where it is expected to impact the coast of the Carolinas with heavy rain and gusty winds through the weekend. Tropical storm warning has been issued from South Santee River, South Carolina, to Duck, North Carolina, including Pamlico Sound. And guys, looking at this shot, which is focused right on the southeast, you can see the remnants, and that's why it's cloudy if you're in central Mississippi and out sections of Alabama and Louisiana, Texas. This is the remnants of that storm that impacted Texas, and then yesterday started just moving back north, bringing moisture right back over the areas that it had rained on in the beginning of the storm. So I'm sure there was some flash flooding here and there and all, but mostly all I can say is being we do a little farming here, it was a blessing. And I said, thank you, Jesus. And I meant it, because it's been severe. The heat has been severe. We've seen CERN and how it's weakening the shields and allowing more radiation to penetrate to the surface of our planet, burning crops, burning people, burning animals, trees dying. And that continues. Here we have, which appears to be pretty much a dry center of Bonnie. See it right there still, 1 foot on land, 1 foot in the ocean in northeast South Carolina. It looks like most of the moisture is to the south of it here, being fed by this offshore flow and by the flow that's coming up out of the Atlantic. See that? And taking a look at both the satellite with the infrared, you can see where the higher cloud tops are and the moisture. All of this is south. So that's a good thing unless you need rain very badly. Now, it looked like you may have gotten some yesterday along the coastline there, but it's pretty dry right now with some wind. But again, you're going to have the influence of the tide, high tide, mixed with this onshore flow. I guess you would call it storm surge. And also, you can clearly see, as this fades out, getting into this high pressure, the remnants of that system that we talked about moving into Texas after it dropped rain on us here and through Louisiana, and then moving back up over Houston again, bringing it back. So I'm not complaining at all. And wherever you can get it now, take it. You guys along the coast here, you're getting a little bit in the Florida Panhandle area. It's been dry, but we're getting to that season to where we hope we get more of these tropical storms. We don't need any major hurricanes, although it's predicted to be above average year this year. We don't need those, and we don't need that damage. But that's the way the earth cools itself, as these clouds spin across the oceans, which get very warm. Then that funneling, that spiral that you see, just like a giant tornado, releases that heat into the upper atmosphere. It cools it, and it keeps the earth from overheating, so we have to deal with it. Now, this is our magnitude pulse. This was at 2:35 a.m. this morning Universal Time, which would have put it around 10:30 or so on the East Coast. Again, today, Universal Time. Notice the distortion in the bottom part of this. It gets worse. This is the effects of CERN, and CERN has their energy field created by that 17-mile superclouder, a football field deep in the ground, which is connected to the underground lines of force that are generated when solar energy or any kind of energy from space hits our shields. That's how your compass works. That energy travels into the ground. It creates ground currents, and CERN is built right in the northern hemisphere section at the right latitude to be in those fields. So as solar energy hits the Earth, two things happen. CERN, I think, takes advantage of that energy, and at the same time as their energy is increased because of this, where they're picked up, they're underground. They have tapped into that energy. There's other sources that they have, including electrical grid. But they use so much energy that when it first started years and years ago, they could only run at certain times because people couldn't run their electric heat in the Franco-Swiss area on the border there. Anyway, it's a feedback thing. It feels it, but when CERN cranks up, its magnetic field is 100,000 times stronger than the Earth's very delicate magnetic shield that you're looking at. And you see these distortions, and it gets worse as we play this through, and that's where the radiation pours in, burns up your plants, burns you and your animals up, and dries up the lakes and the rivers. Let's look at this. Going forward, look at the distortion, southern hemisphere, northern hemisphere starting to bend. You got the pressure coming in from the sun from the right. The Earth, the center of the dot, look at this. The dot in the center is the Earth, the white side is the sun-facing side. We normally have the shields moving in and out like that, but they maintain their round outlook. Look at that. Look at the energy that's pouring in. I'm going to back that up just a second. Now, going back to 813, remember these times because CERN uses the same universal time, and you can look when CERN spikes. I'm going to show you that, and when these events occur. Notice this light blue area here. This is penetrating radiation into our planet. Look how it wraps around. These are the cusps we talked about. They occur on both hemispheres. Now, this is burn off in the red, but when you have this is what is going on. If they want to talk about climate control, this is the largest machine on the planet, and it happens to be right now, again, whether it's a side effect or planned effect of what they're doing, it has a drastic effect on our planet. No greater weather crisis or climate crisis has ever been like what we're seeing now with this technology. And you know where that technology comes from. But let's move forward, but look at that. This is energy pouring in. Here the shields at the top have been into this white dot. That white dot are the two GO satellites, 17 and 16. They're represented by the X and the diamond shape. As they rotate around our planet, they're sending back the information that you're looking at as they're exposed to it, that and other information, and multidimensional. But again, bending into that band. So look at how close the radiation is that normally would not be here if these shields were left alone. Now let's go forward through the day. Check that out. Look at that at the top, back into the satellite bands. You want to know why everything's drying up and everything's burning up? And they want to carbon tax us. Check this out. This is 1651 UTC time this afternoon. Well, it's 11:18 here Central Time. It would be 12:18 on the East Coast. Now, I had backed up the magnetopause monitor to 0230 this morning, Universal Time. And you can see that both beams had spiked. We're coming down from that at nearly 7 tera-electron volts each. That's 7,000 giga-electron volts. That's how powerful CERN's magnetic field is. 100,000 times greater than our Earth's shields. Now, those are the beams. When the black line starts rising, that's the beams creating even more power. And we saw that all the way up. Look at this, constantly holding this peak right there the entire time. And you're seeing the damage. You can take this video, if you guys want to do a little homework on this, do a video on it if you'd like. I don't care. You can use any of my videos. But take this, back the video up, take a screenshot of the, or mark down the times that you saw the worst spikes on our magnetopause just before this section, and you can match it to the worst sections are the highest points of power here. Now what's interesting to me is this is where we normally would see the two dots moving around in each box, beam 1 on the left, beam 2 on the right. And when they manipulate these magnets that encompass the 17-mile loop and get these things going at the speed of light, and they have to keep it at like 2 degrees, minus 2 degrees Celsius, the same temperature as outer space, they say, in order to keep it cold enough to run this much energy through. If not, everything would burn up. If one of these sectors get too hot, then they shut everything down. But what we're not seeing are any beams in here. Now notice that we're live. As I'm speaking, it's 11:23 a.m. Central Time, at 18:23 Universal Time at the top center. So no beams there, but the power continued to run hot for a long time, even after the beam shut down. We'll go back and I'll show you what I'm talking about. They're not running now, and everything's starting to drop. Now, we were watching that, the two beams back at 2 a.m. right here, about 1:30 or 2 a.m. You see where it's peaking at. And the first ones that we were watching, you would see those two dots inside the beam 1 and beam 2 box colliding, or getting very close to colliding, to create this power. But notice that even that after they drop probably around 0300 a.m. this morning Universal Time, they remain down. See this? But the power, it's like once they had done their job, the power was up and running almost on its own. Once it got cranked up and going, it was taking advantage of the shield power, the magnetic field, even though it was distorting it, almost destroying it, it looks like. Of course, it's created by God, and man will not be able to destroy it, but they can cause a lot of damage. And that's what we're seeing right now. It's running hot, it's running quick. But again, if you'd like to take this chart here, look at the times at 0200, go back and look at the information on the magnetopause. You can see what's going on, because on normal days, like for 3 years, from 2018 until now, before CERN cranked back up a few months ago, we would see the magnetosphere bend under solar wind or pressure from a solar flare or anything like that, but not those distortions. This is actually CERN's huge magnetic field reaching up, pulling down our shields and creating the problem with the crops. Although we don't need any more, it's a tribulation of man by man. Remember that. Cutting down the diesel, the fertilizer, gasoline. We're watching it, guys. You watch it. It's a heads up. Be safe.